Hello viewers, welcome back to my channel. I hope you are doing great. If you haven't subscribed to my channel yet, please go ahead and subscribe. I have created bunch of playlists to cover various categories of the problem such as linked lists, trees, graphs, breadth first search, binary search, depth first search, dynamic programming and so on. Please check them out. I have uploaded the code for this particular problem to GitHub. You can get the link from description below this video. Let's jump into today's problem. Rearrange words in a sentence. Given a sentence text, a sentence is a string of space separated words in the following format. The first letter is uppercase. Each word in the text are separated by a single space. So basically we are given with a sentence and the first character is an uppercase letter and all the words in the sentence are separated by a single space. Your task is to rearrange the words in text such that all words are rearranged in an increasing order of their lengths. If two words have same length, arrange them in their original order. Return the new text following the format shown above. So once we rearrange, we need to make the first letter uppercase and all the words in the text should be separated by single space again once we rearrange basically. So what are the conditions for rearrange? There are two conditions, right? So one is the words should be increasing order of their lengths. But if two words have same length, right, arrange them in the original order. So whatever the original order in the sentence, right, we will be arranging in that original order. So let's go ahead and understand this with an example, right? So Leetcode is cool. Let's say that's the word, right? So Leetcode, how many characters it is? 8 characters, right? And this one is 2. And this one is cool is 4. So now if we sort, right, what it will be 2, 4, 8, right? That's what it is. So the corresponding thing, it will be is cool Leetcode, right? Ideally this is the one, right? Is cool Leetcode. But we need to arrange the sentence in the format shown above. That's what it is, right? Return the new text following the format shown above, right? So what is that? First letter is in the uppercase. So let's transform I to the uppercase. And each word is separated by a single space. I think I already have single space across. So this is our answer, right? So this is our answer. So that's how we need to do. Right? This is a simple case where we are arranging them in the increasing order of their length, right? So that's the first condition, right? So fortunately there are no words with same length, right? So let's see if there is another thing with same length, right? So let's see this one, right? In this there are some words which are the same length, right? So let's say keep is 4. Com is 4, and is 3, code is 4, on is 2. So with that, what we are going to do is 2, 3, 4, 4, 4, 4, right? So this is a pretty complicated situation, right? We have 3 words of the same length, right? So now let's try to fill up the first things, right? Because there is no collision with that. So on, right? On. And next thing is and, right? Now for 4, which 4 I need to take is the question, right? Since we have to keep the order, right, the original order it said, right? So arrange them in the original order. So what is the original order? Keep, com, code, right? So keep is coming first. So keep, com is coming second, and code is coming third. And what we are going to do, the first character we need to make as capitals. So this is our answer, on and keep com code, right? That's what it is. So whenever there is a collision between the lengths, right? So if there are more words, 2 or more words have same length, we have to arrange them in the original order of the sentence. So like keep com code, they are in that order, right? So this is the idea. So we are given with a sentence and each word is separated by a single space, right? So now what we are going to do is, since we have to play with words, we need to convert that given sentence into words. Basically, we split the sentence into words now, right? And we need to know two things, right? What is that? The word position and the word length. Two things. If we know two things, then only we can arrange into another sentence, basically a new sentence, basically, right? So we need to know two pieces of information, right? So what is that? The length of the word and also the position. So what we are going to do here is, if we have the word, we can get the length of the word pretty easily. So what we are going to have is a placeholder class which will keep track of the two pieces of information that we need. What is that? The length of the word and the position of the word, right? But if you have the word itself, right, it's easy to have the position of the word, I mean length of the word anyway, right? So what I'm going to have is a word and its position in the placeholder class, right? So let me show you the placeholder class for a second, right? So this is a placeholder class which I'm calling as node. Ignore the naming for a second. So it will be public string s and public in position. So string is a word here. Basically this is a word, and the position is the position in which, I mean position of the word in the sentence basically. So if you go back, right, so position of keep is 0, right, and com is 1, and is 2, code is 3, on is 4, like that. So I will be keeping the position of those words, right? That's what it is. So once I have that, I will be generating a list of objects with word and position, right? And I will sort based on the rules. What are the rules? First rule is increasing the order of length, and second rule is if they have same length, arrange in the original order. So with those two rules, I will sort it. So once I sort them, right, so I will have basically in this format 2, 3, 4, 4, 4, 4, right, and they are in this format. So once I have them in this particular object list, right, what I need to do is I need to extract the words from this list and put back into the sentence format, right? Put back into the sentence format and make the first character as uppercase, right? Make the first character as uppercase. So that's what we are going to do. So basically the steps are simple. First, you have to split the sentence into words, and the second thing is prepare a list of objects, such as you are keeping track of the word and its position. So once we have list of objects, you sort them. That is in step number 3. Once you sort, in the step number 4, you just join the words with space in between them. That's what it is, right? That's what the second rule. And what you are going to do is convert the first letter in that sentence to uppercase and return it. That's it. So we will do those 4 steps and come up with the final answer, right? So let's go ahead and look at the code for this particular idea. So I already showed you the placeholder class which keeps track of the word and its position, right? So let's go ahead and look at one more time. Word and its position, right? And next. So just for the sake of converting this first character into lowercase, right? So I am taking this text to lower and splitting it by space. So now I have all the words in the strings, strs, right? So I initialized the position to 0. I am declaring a list of words. This means list of objects basically. So these are the list of objects where the type is node. What is that node exactly? Node will have the word and its position, right? So now I will go through each string in this strs and try to add an object into the words. So the object will have the string and its position, right? The position will be incremented for each string, right? So now I have a list of objects. So these list of objects will be sorted. I am using a custom sort, okay? I'm calling it as new arrange compare. This is a custom sort, right? We will go and see what is the custom sort doing. So essentially the custom sort has to do 2 things, right? And it has to follow 2 rules. One rule is it should arrange in the increasing order of their lengths. Second rule is if the 2 words have same length, they should be arranging in the original order, right? Original order of the positions of the words. So that's what this arrange compare is going to do for us. So I sort using the custom comparer. So once I sorted, the words are in this particular format, 2, 3, 4, 4, 4. Basically I am having the with the lengths, but assume that these are just the words, right? So I have the words. So now I get the words.select w.s. So this is the lambda expression to get the words, and join by what is that? Space, right? So that is what we need, right? They are separated by a single space. So we are separating by single space. Now I have the final string. And one more thing we need to do is convert the first letter to the uppercase. So I get the first letter, and then before returning I am converting that to uppercase, right? And returning the string. Now go ahead and see what we are doing for the arrange, compare, custom sort. So this one we are passing in node type, right? So node type will have two things. What are those? String and its position, right? So now I will get the length of the string A from node A. I will get the length for second string in node B. So if the lengths are same, what I should do? If the lengths are same, if the words have same length, arrange them in their original order. That means whatever the position. So I am comparing the positions and returning the position comparison. If they are not same, then you compare the lengths and return. So this is the custom sort that we are going to use as part of the word.sort, right? So that's what will be used to sort the words based on the length as well as the position, right? So now that we are able to solve this and return the final answer, right? Let's go ahead and look at the time complexity and space complexity. Time, space. So we are given with the sentence, right? The text is sentence, not the word, but we are playing with the words. We don't know the number of words in the text. For example, I am assuming n is number of words, right? N is number of words. It's not text length, right? It's not text length unless the whole text is a single word, okay? If it is a single word, then you don't need to do anything of this sort, right? It's just whatever it is, right? But I am assuming n is the number of the words, not the text length. So normally in the string algorithms, right, you would take n as a text length, but here it is the number of words. So I'm just assuming n is the number of words. So if n is the number of words, right, I'm going through the first I'm splitting and going through the number of words, right? So this will be order of n time complexity, right? So now I'm sorting these n words, right? So any sorting algorithm that we take, so far it's order of n plus we are sorting. I would say best sorting algorithm will be order of n log n, right? So the total complexity is order of n log n. And if you would like to add this one, right, adding or generating the final string, this would also take plus order of n, right? Order of n, basically order of words, right? So that will be totally order of 2n plus log n, right? So order of 2n plus n log n, right? So normally n log n is greater than n, right? Normally n log n is greater than n for a valid n, for high number of n, basically, not for like 2 or 3. If n is equal to 2 or 3, doesn't matter much, but if n is large, maybe n is a million, right? So then 2n is much less than n log n, right? For those cases, we will remove 2n from the big O notation and we will say the total time complexity for this particular algorithm is order of n log n, right? So let's go ahead and look at the space complexity, right? So how much space we are essentially using, right? So there is a list of objects that we are generating, right? The words. So each word will have the position and the word itself, right? So we don't know again the word length, right, to start with. So again we will go with number of words, right, n number of words are there. So we need n such spaces, right. I am assuming there will be 1 unit of space needed for word. That 1 unit can be anything, it could be 8 bytes or whatsoever, right. I am just saying 1 unit of space. I don't know what is that unit is. So each word will have different length, so that unit will be different, right. So I cannot quantify saying okay each word will be taking the same number of units, right. That's why I'm just going with a uniform way. I'm taking 1 unit of space for each word. So I have n words, right. So n such objects are there in here. So I would say order of n to start with, plus, and I have this space where I'm splitting and storing in here, right. That would also be order of n, plus we are making the final string, right, which will be another order of n, right. So basically we are using order of 3n space, right. So since we are going to ignore the constants, we will say the total time complexity for this algorithm is order of n. So the space complexity is, sorry, not the space time complexity, it is space complexity. Space complexity is order of n and time complexity is order of n log n. If you have any further questions, please post them in the comment section below. I have posted the code to the GitHub repository. You can find the link in the description below this video. If you haven't subscribed to my channel yet, please go ahead and subscribe and also share among your friends. Please click on the bell icon so that you will be notified about all my future videos. Thank you for watching. I will be back with another problem very soon. Till then, stay safe. Goodbye.